Good day, my amiable viewers. You're welcome back to class. As you already know, my name is Mr. Israel. In our today's discussion, we are going to pick a topic from chemistry in the area of practical chemistry, precisely salt analysis. These questions we are going to consider are carefully selected past questions, which, God willing, you may equally encounter in this forthcoming Waec. So just listen and let's get started. Now, the first question says, sample C is a mixture of two salts. Put all of C into a beaker and add 10 cm of distilled water. Stir the mixture thoroughly and filter. Keep both filtrate and residue. Test the filtrate with litmus paper to about 2 cm of filtrate, add barium chloride followed by dilute HCl. To another 2 cm portion of filtrate, add sodium hydroxide and heat. Transfer the residue into a boiling tube and add a few drops of iodine solution. Before we go far, if you listen to some of the videos I've already given you, you will find out that I gave instructions. Apart from the titration aspect, I also gave instructions on what you must follow, precautions you must actually take cognizance of when you are carrying out salt analysis. So as we are going, I'll be explaining them in detail. So this is salt that we're giving. It says a mixture of salt. This is salt. And the question says, put all of C in a beaker and add 10 cm of distilled water. Usually it's a boiling tube, we normally add it. So whether it's a beaker or boiling tube, it's all the same thing. So let's see how it goes. This is a boiling tube we are going to use. Let's add it carefully. Wow, all of them has gone in. Let's see if there's still any remnant left. Okay. So it's a mixture of salts, and this is what we have. You can see it. It says add 10 cm of distilled water. Doesn't mean you have to measure 10 cm. What they actually tell you, add little water. This is distilled water. Can also be ordinary water, depending on what they give in your school. You see it. Ensure you make it 1/3 or 1/4 of the solution of the boiling tube. So in this case, we are using this boiling tube. So it says stir the mixture thoroughly and filter. We stirred it. The next thing is to filter. Let's see. Once they say filter, they must give you filter paper. And this is filter paper we are giving. This is how you fold it in 2 ways. Hold it like this. Fold it a second time. And you are good to go. So you can see, you now put your hand in one part, not this side, one part, making it, you know you have already made it a cone, and you now insert it like this. After inserting it, try and sprinkle some water on it to make it easy for filtration to be carried out. Now we have done that. You can see the residue is settling down. They say filter. You put it in a different boiling tube. Even if it's test tube, it doesn't actually matter. All you need to do, you filter, stir it very well, and pour it through. Stir it again, pour everything once. Good. So you can see it passing through. The one that is passing through is the filtrate. The one that will remain on top is the residue. So we just exercise patience a little and see how it goes. So it's still draining through. It's draining through. So in order to do that, as you are doing that, you draw your table. Say test, observation, inference. You can say inference or result. Either of them is correct. So put all of C into a boiling tube and add 10 cm of distilled water. What you now do, you say C plus water. If you like, put the same thing. You can see there are some residue stain on top. Look at the color, like that of water. It doesn't have color. Colorless filtrate, and what is on top is white residue. You state it like that. You don't just finish your work before you start writing. You say colorless First of all, you tell them whether it dissolve or not. Don't ever use the word soluble. Since about 2 years now, that word soluble is no more accepted under this process of dissolution. In most of your textbooks, they still use soluble. It is wrong. They normally underline it and mark it wrong. You say C, sample C dissolves partially in water. Colorless filtrate and white residue. So at the inference part, you say soluble and insoluble salt is present. The soluble one is the one that have dissolved to form the filtrate. The insoluble one is the one that remains on top of the filter paper to form the residue. So it has completely separated. So while we are waiting, we can put it here so that we'll continue our work because of time. Remember, there is no much time, just 2 hours. Now, we have done the first one, filter. We say colorless filtrate and white residue. When they are marking, they mark for dissolution, they mark for colorless filtrate and white residue. Then here there are 3 marks. Then the second one, keep both filtrate and residue. That is it. Then B, test the filtrate with litmus paper. So we bring filtrate. So as you can see, test the filtrate with litmus paper. That's what the question says. We now remember, if you are testing with litmus paper, make the litmus paper first of all damp by dipping it in water. You cannot use only one type of litmus paper. Before, Waec used to give marks for one type, but this time, if you don't test with the 2 litmus paper, they don't give you the mark. So let's test with the 2 litmus paper. This blue litmus paper, make it damp in water. Let's test it and see. Just let the filtrate touch it. You can see it has changed it. It appears as if it's purple, but it's not purple. You see it? It has changed the blue to red. You can see the difference. Blue to red. So change the blue to red. You also test with red litmus paper. Dip it and make it moist. No effect on red litmus paper. So you write it. Everything you do, you must write. That's B. This A. B. Test the filtrate with litmus paper. Filtrate plus litmus paper. You say litmus paper, blue litmus, wet blue litmus paper turns red, while no effect on wet red litmus paper. Because it changed blue litmus paper to red, it means the solution is acidic. So it says solution filtrate is acidic. Remember, it's not an acid, it's only acidic. So you cannot say filtrate is an acid, you say it is acidic. If you say it is an acid, they mark it wrong. So let's go to the next question. He said that's Roman figure 2, this is Roman figure 1, Roman figure 2, B2. To about 2 cm cube of filtrate, add barium chloride followed by dilute HCl. Now you have to shade the filtrate. When they say 2 cm cube, what they're actually telling you is to take a little from it. You don't need to share it into 2 or start looking for how to measure it. You can say the filtrate is colorless. 2 cm cube, this is assumed to be 2 cm cube. Nobody tells you to measure it. Just put little. Add barium chloride. This is the barium chloride. Let's try and add. You see, just add little drop of barium chloride. You can see it has turned to white. White, we call it white precipitate. Don't say white solution. White precipitate. We got it from this. You can see the difference. This white precipitate. When you added barium chloride, it was white precipitate. Then they said, followed by dilute HCl. This HCl. Just follow the steps. You don't have an issue. You will not have an issue. You see, it's white precipitate. You add HCl. You can see it did not dissolve. Instead, it forms another solid layer. You now say white precipitate in dilute HCl, white precipitate in barium chloride, insoluble in dilute HCl. This is the only time you are permitted to use the word insoluble, not under dissolution. That's when you added water. You are not permitted to use soluble or insoluble there. So here you now see first portion of filtrate plus barium chloride. If you don't put aqueous, these are the precautions. You must put aqueous here. AQ, meaning it is dissolved in water. If you don't put aqueous, they said they now write for you TOS, test on solid, and everything, that column is 0. So don't miss it. Plus barium chloride, then plus dilute HCl. Since you have put dilute here, you don't need to put aqueous. Although some students say they will still put, it's okay. But dilute stands for aqueous. So here you have white precipitate, PPT, insoluble in barium chloride, insoluble in dilute HCl. So that is what you have under observation. If you fail the observation, no matter what you write under inference, it's wrong. The score you get for inference is based on the observation, correct observation you make. Therefore, since you have written this one is white precipitate is 1 mark, insoluble in HCl another 1 mark. Otherwise, there are 3 other marks you need to not to play with here. White precipitate in barium chloride, you see SO4 2 minus, SO3 2 minus, CO3 2 minus suspected. That's under this. Then for this, you see, because it did not dissolve, you see SO4 2 minus present. You can see it. If it has dissolved, then it can either be SO3 or CO3. Then we use SO3. The solution will separate the two. The one that is soluble is SO3. The one that is insoluble is SO4. If there's effervescence, then you go for CO3. Let it be close, insoluble. So we have done that. The next one we go for is to another 2 cm cube of the filtrate, sodium hydroxide, and heat. You now see Roman figure 3. Second portion of filtrate plus NaOH. Don't forget aqueous plus heat. Let's see how it goes. So you take filtrate again. You can use normal situation. You have to use test tube holder. You can use either of them to heat. The heat generated is not strong enough. But when you're actually heating, you have to use your boiling, this one. This is what you use to bake. It doesn't matter. But all that is necessary, I use boiling tube. Use a test tube holder. So this is what we are going to improvise for this work. Let's see how it goes. They say add sodium hydroxide. So this is sodium hydroxide and heat. We already added sodium hydroxide. Here you have no visible reaction. The sodium hydroxide, you say no visible reaction. Here you put dash. They say it should heat. So we'll just heat like this. can see the flame. What they actually wanted to do is to test the gas produced with litmus paper. Let's see. This is red litmus paper. Let's see what happens. You can see it turns red litmus paper to blue. Let's use the blue litmus paper. No color change, it still remains blue. While the other one turns became blue from red. So if you use blue litmus paper, no color change. But when you use red litmus paper, it changes it to blue. So you say second portion of filtrate plus sodium hydroxide plus heat. Blue red litmus paper plus heat. Okay, another thing we need to know is this. As you test it, use heat, you have to perceive the odor. Colorless gas is released. You see colorless gas. That's when you heat. Colorless gas with characteristic choking smell. Spell it properly. Smell. Gas turns wet red litmus paper to blue, but no effect on wet blue litmus paper. So here, no visible reaction, don't write anything. Colorless gas, you say NH ammonia, NH3 gas from NH4 plus suspected. That is under colorless gas with characteristic choking smell for this column. That's when you suspect that. Then gas turn red litmus paper blue, you say NH3 gas from NH4 ion present confirmed. So this is the confirmatory test. They said that you use this or use concentrated HCl. We are not using that because questions do not require that. Then the next one, since there's no speed, we are going to use the top. The next one says transfer the residue into a boiling tube and add few drops of iodine solution. Remember we say white residue. You can use here. Let me just delete this part. That's C. Residue plus iodine solution. Iodine solution means aqueous. Let's see how it goes. This is the residue. This is the residue we have here. So let's remove this and scoop it. Let's rinse it in case there's any remnant left. And scoop it or use spatula. If you are not allowed to use spatula because of damage to the boiling tube or test tube, you can scoop. But I will always prefer use of spatula. So this is your iodine solution. Iodine solution. You can add it and see what it gives us. Let's see. Just add little few drops. can see it. It gives a blue-black coloration, not black precipitate, blue-black coloration. Between blue and you see at the side, you see blue color. Then if you turn it like you see blue color, you can see blue color here. These are all blue color, but the solution will appear black. If you still turn it like you see blue color, so it's blue-black coloration, blue-black, not blue-black precipitate. So that's a simple test for starch. You see residue plus iodine solution, blue black coloration form. Remember, no precipitate because already a solid. You see starch present. So this is the end of the titration. And remember, it's usually 20 marks according to Waec standard way of marking. Viewers, that's all we can take for this video. If you have any comments, any observation, can always put it in the comment section. Again, please kindly help me. You people are trying. I can see the progress. A lot of people are subscribing and I'm very impressed. But those of you that have not made up your mind to subscribe, it's time to make up your mind, because towards the Waec period, we have a lot of bomb experiment or analysis we are going to present in this channel. So be updating yourself with it. Thank you very much and God bless you.